In example 6, you're asked to either write an inequality in a standard form in interval notation, or the vice versa, if you're given interval notation, to write it in a more standard inequality form. Inequalities are used a lot to describe domains and ranges, which we'll get to in the next example. However, this is often seen in calculus classes and sometimes other advanced math courses, so that's why it's used a lot and seen, and make sure that you go over. Doesn't matter which form you usually use, just make sure you know which form it is. This is more of a shorthand. So if you have the inequality x is greater than -4, what interval notation does is more or less describe what you would see on a number line. So if x is greater than -4, that means on a number line, at -4, you would see an open circle and things would be shaded to the right. And so you would indicate this in interval notation by having an open parenthesis at -4, then a comma, and then to the end point you would write infinity with a closed parenthesis. Now, make sure that you are aware that, this looks like you're giving coordinates because you see the two parentheses in particular here, but make sure you always know if you're given an ordered pair, or it looks like an ordered pair, if it's an interval or if it is, in fact, an ordered pair, an actual location. You're not going to have a location of infinity because that's impossible. And another thing you always want to consider is that you will never, ever have anything but a parenthesis on this. A bracket would indicate you equal infinity. You can't equal infinity. So you would never have a bracket wherever there's an infinity or a negative infinity. So just be aware of that. For -2 is less than or equal to x, which is less than 5. That means that the -2 is included, the 5 is not. So on a number line, it would look like this. You have a closed dot at 2, an open dot at 5, and you'd shade between them. And so in interval notation, you would have a bracket at -2, comma, a 5 with closing off with a parenthesis. In interval notation, now we want to write the inequalities to go along with it. You have -3, comma 3 in brackets. That means on a number line, you would see at -3 and 3 closed dots with the area between them shaded. That means that x is between these two and include these two. So you would see -3 is less than or equal to x, which is less than or equal to 3. Sometimes it might even be expressed with an and statement. It would be x is greater than or equal to -3 and x is less than or equal to 3. But usually and statements are usually used with these in between type notations. 2, comma 7 with parentheses. Again, it looks like an ordered pair. It isn't, because you're told it is an interval. So on a number line, you would see at 2 and 7 open dots with the region between them shaded. So you would write this as 2 is less than x, which is less than 7. In this last one, parenthesis -5, comma 8 bracket. On a number line, you'd see an open dot at -5, a closed dot at 8, and the region between them shaded, which means you would have -5 is less than x, which is less than or equal to 8. Now again, inequalities and interval notations are often used to describe domains and ranges of functions. Interval notation is used a lot of times because it's just shorthand. In example 7, you were given these two graphs and asked to determine what the domain range of A and the domain range of B are. And it was more of a multiple choice type question for you to choose from. So looking at this, for the domain of a function, you always want to look, okay, well, how far left and how far right do we go? Now, function A, first to be noted, is a continuous function. Notice that it is it's a curve, there's no breaks or anything in it, it's a continuous function. So it starts at -3, it goes to 4 as far as the x values go. And so your domain in interval notation would be everything here to here. And so -3 to 4 in brackets would be the domain. For the range, you always want to go from lowest to highest. The lowest point here is -4. The highest is 12. So the y values, starting here and ending here and everything between them shaded. So you would have bracket -4, comma 12, close bracket. Function B, on the other hand, it's something that's not brought up in your textbook and emphasized a whole lot, but it's still worth mentioning. This is a discrete function. And sometimes if you just have a table of values and nothing else, or if you just have some ordered pairs and nothing else, you have a function that's being described discretely. And what a discrete function is, I mean, you notice it's the same general pattern. It still has the same like far left and far right points, same lowest and highest points, but you notice here there's just dots here. Therefore, here, I don't know what happens between -3 and -2 as far as x values go. I don't know what happens between -2 and -1. Those are not defined. And so when I have discrete functions, I can't use intervals to describe the x values or y values in the domain and range respectively. All I could do is list them. Notice here that -3, -2, -1, 0, 1, 2, 3, and 4 are the only values of x that have a point associated with them. And so that's why I have to list them in more of a set notation and say these are the values of x and that's my domain. In the range, same thing. I only have these y values, -4, -3, 0, 5, and 12, and so I have to list them in this set or roster, sometimes it's known as roster notation. And so be aware of that, because sometimes you will see a domain and range given this way. That means that's because it's a discrete function. And anytime you're given information on a function and it's a table or anything like that, and that's all you don't have an equation, you don't have a graph that shows that values between certain other values are defined. If all you have is a table or sets of ordered pairs, you have to assume that those are the only defined values, so you have to treat it as a discrete function. But that's the end of this problem, and that's the end of this video. If you have any additional questions, please make sure to bring them up in class.